afternoon, everyone. It's a great honor to be here. My topic is the prevalence genetic drift of hemagglutinin and antiviral resistance of influenza A strain to viruses circulating among Shanghai children 2009 to 2012. Well, the influenza virus is a major cause of acute respiratory disease. Among the viruses, types of the subtypes of influenza viruses circulating every year, the A-H3N2 subtype causes the vast majority of influenza outbreaks. Well, the pandemic of influenza have 3 times in the last century. The first is from 1918 to 1919, and the second pandemic is from 1956 to 1958, and the third is from 1968 to 1969, and it killed a lot of people. Influenza virus is a negative sense single-stranded RNA viruses. They have 3 important protein on of the influenza. The first is HA hemagglutinin. It's a protein the viruses use to attach to the host cell. And the second is neuraminidase, and it enables the virus to be released from the host cell. And the third important protein is M2 channel. It allows the proteins to move through the viral envelope, and it's necessary to replication progress of the virus. The HE is very important, and there are 5 epitope regions A to E in the HA. And the vaccine is very important, but if there have mutations of those epitope regions, and the vaccine will be useless. Okay, antivirals. There have 2 antivirals in China by the FDA approved. The first is M2 on channel blockers amantadines, and the second is neuraminidase inhibitors. It's oseltamivir. A single amino acid substitution at any of the 5 residents in the M2 is thought to confer resistance to amantadines at position 26, 27, and 30, 31, or 34. Also, the mutations in the NA genes of the influenza H3N2 virus are used as indicators of oseltamivir resistance. It contains the position 190, the 292, and 294. The chart shows all of the position. It's correction about the indicators of oseltamivir resistance. So the drug resistance of this chart shows the amantadines drug resistance. It have a remarkable high rise of the resistance frequency in 292. This is a paper published in Lancet in 2005, and from then the amantadine resistance is bigger, very high problem. And there have some research about the oseltamivir resistance, and we can see that there have a little the rate of resistance is low in the H3N2 subtypes. So far, there have no data in Shanghai and on prevalence of influenza in children. And there are also no data in Shanghai. In our city, have no data about drug resistance in children. So our purpose, we want to characterize the epidemiology patterns and the genetic evolution of HA epitopes of influenza A strain 2 viruses circulating in Shanghai. Also, we wanted to evaluate the efficacy of amantadine and oseltamivir in the treatment of influenza in children. Well, it's our method. First, we want to detect influenza. We collect samples from the outpatient. We collect the nose swabs or nose or short swabs, and we extract the total RNA, and then we use real-time PCR to detect the influenza. We detect the whole type of influenza. It can include it contains influenza A strain 2, and a seasonal H1N1 and the pandemic H1N1. Also, we detect influenza B. And then the partial M2, the HE1, H1 contains all of the epitope regions, and the NA genes from A strain 2 was amplified by RT-PCR. So let's see our results. In the 3 years, from 2009 to 2012, we collect the 3,475 samples, and there have 978 is positive or influenza. Well, and there have 314 strains it's strain 2, and it's 35.2%. Well, it's the trend of the AH3 and 2. This chart is of the influenza for the trend of all of the subtype influenza. It contains H1N1 and influenza B and AH strain 2. We can see that every year it have a epidemic trend of influenza, and this chart is a trend of AH strain 2. You can see that in the first year, it's from 2009 to 2010. The epidemic is from June to October, and the second year, it removed it from August to February, and in the third year, it's in spring. It's from January to May. Yeah. This chart is antigenic drift of its strain 2. The animal see the variations in HE1 in the 2009 and 2010 seasons. It's compared to this is the vaccine strains compared to the vaccine strains. They have a lot of mutations in the epitope regions. In the first year, it's in the region A, B, and C. And in the second year, we can see that it's the mutation is in the C and D. Yeah, this is the third year. So in the first year, most of the mutations in the region A, B, and C, but in the third and second year, it removes it. The mutation is in the region C, D, and E of the epitopes. Well, it's a surveillance of the resistance. We find that there have all of the strains have a mutation in the 31 of the M2, and it's indicated that resistant to amantadine. And we didn't find any change, any mutation in the NA. It's in the NA, yeah. So, conclusion, the genetic drift occurring in the HA epitopes is consistent, and amantadines become ineffective. Oseltamivir remains the drug of the first choice and the continuous monitoring of the antigenic drift of influenza is necessary. Okay, thank you.